Tables are two types. Tables are two types. Mainly tables are two types. So we know partition, that's why I'm covering these points. Mainly tables are two types in Hive. One, managed table. One managed table, and second one external table. External table. So we discussed partition, right? Partitioned, partitioned. We can create partitioned, partitioned managed tables, partitioned managed tables, and partitioned external tables. So this is default. So non-partitioned, non-partitioned, non-partitioned tables. Non-partitioned tables are called these. This by default we call it as non-partitioned tables. Okay, and bucketed tables. So we can create a bucketed. We can create a bucketed managed tables and bucketed external tables. External tables. Non-bucketed tables means these are non-bucketed tables. So default tables are called non-bucketed. Default tables are called non-partitioned tables. Finally, we are going to create in this way bucketed with partition. So generally, in our application development, we created bucketed with partitioned external tables. Inside bucketing, we create partitioned external tables or partitioned with managed tables. We created either this approach or this approach. So this one is most of the times we create Hive tables in this way, bucketed with partitioned and external tables, partitioned external tables, are bucketed with non-partitioned managed tables. So in this way we improve performance of retrieval time. To improve retrieval retrieval time, to improve retrieval time, we create bucketed with partitioned external tables or managed tables. So that's why people will ask three questions. Bucketing related you will get one question, partition related you will get question, managed or external table related you will get one question. Compulsory you will get these questions. Yep, in Hive. So table feature alteration is depends upon table creation. Okay, let's see what is bucketing. First let's see drawbacks of partition table. So we are creating partition based on city column. For sales data we are creating partitions, primary partition department number. Primary partition, table, city column as primary partition, department number as sub partition. Primary column city and sub partition is department number. Yes, so total sales we are creating partitions, city and department number. So assume XYZ company has sales in entire entire India. So India, assume 200 cities, 200 cities with they have multiple departments. So they have 10 departments, 10 departments. So 200 in that 200 they have 10 departments. So each city again they divided 10 sub partitions. So it divides 10 sub partitions means, let's see, it is going to create for each city. So city 1 and 1 to 10 like this, 200 cities, 200 cities. So data is duplicated, right? Lot of data is duplicated. If data is duplicated internally, assume this complete sales data is sales data is uh, let's take 1 petabyte of data, 1 petabyte, 1 petabyte data. Complete sales data is 1 petabyte. So in this we cannot expect how many duplicate records are presented. Means if data is duplicated, automatically number of blocks are increased, right? Number of blocks are increased. If number of blocks are increased, then metadata automatically increased, right? Name node side, metadata is increased, right? So because of this duplication data, metadata is increased and overhead on name node, and we need more memory, and more processing power is required for name node. More memory is required and more processing is required, and always all data nodes keep on sending heartbeat signal to name node, right? About blocks information. So name node does lot of operations. It can do, but this is because of duplicate data we are doing extra additional work. So to reduce this one, we go for bucketing concept. Bucketing concept. So in bucketing concept, so bucketing concept, so bucketing like a partition, but bucketing creates number of, based on the number of buckets we specify, it will create those many buckets. Bucketing works based on hashing. Bucketing mainly works on hashing. Bucketing works on bucketing works on hashing concept. Hashing. So hashing is the fastest algorithm, right? Hashing mechanism is Hashing mechanism is fast algorithm. Searching algorithm. Hashing mechanism is the fast searching algorithm. I think we have different hashing algorithms in data structures. In our academics, we'll get different algorithms. So hashing is fastest algorithm. Yep, it works on hash code value or address. Storage, 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 comma retrieval. All operations works on hash code value or address or value based on the value internally it will go to corresponding bucket and retrieve the value. So comparisons are very fast. Assume we created five buckets. Assume we created five buckets. We have sales data. So in this sales data, we have city one, and each city with some department number. Like this, we have complete all cities. City 200 with the department number 10. Assume city 1 records stored in bucket 1. All the records which are presented in city 1 going to store only in bucket 1. All the records which are city 1 is going to store only in bucket 1. It will not store in bucket 2, because based on whatever the columns we are giving as a bucketing creation or specifying main columns, based on column values it will calculate hash code value or address value, then it will store into corresponding bucket. So all the city 1 columns records are going to store in bucket 1 only. It will not store in another buckets. So whenever you issue query like select star from sales where city equal to city 1, city 1. So first, based on this value, it will find hash code value of city 1. City 1 hash code value. Internally, it finds hash code value of city 1. Then it goes to corresponding bucket. So this bucket generation is based on hash code value. This bucket generation, so bucket creation time, I want 5 buckets, 5 buckets based on city. If I say city, it will create 5 buckets with city column, right? Based on city column it is creating. So while creating also it uses city column as hash. Based on city column hash code value it is created buckets. Then whenever you enter city 1, it finds hash code value of city 1. City 1 hash code value is 1. Directly it goes to bucket 1 and reads. In that bucket, maybe it has city 1, maybe it has city 1, maybe it has city 5, maybe it has city 99. So hash code values of city 1, city 5, city 9 equal to bucket 1. So these are presented. Again internally comparison is happened. Okay. First retrieval point directly when you say city 1, it directly enter into bucket 1 because city 1 hash code value is equivalent to bucket 1 hash code value. So first level it enter into here, but here we have multiple cities. Again internally it will compare, but less comparisons. That's why what we will do, inside bucketing again we create partitions. Inside bucketing we create partitions so that first one comparison, second comparison, we get partition data. So that's why we create buckets. Inside bucket we create partitions. Let's first see how to create a bucketing. So to create a bucketing, we use create a table name and columns list, table name, columns list. Clustered by is a keyword to create a number of buckets. Clustered is a keyword, clustered by, and we pass column name and how many buckets we want. So in this way we create bucketing. We cannot expect because it depends upon the city hash code. So some hash codes match, all hash codes may match with the bucket 1. Assume in 200 cities, 10 cities matched with bucket 1, 50 cities matched with bucket 2. It depends upon the hash code. Yep. Yep. So by default bucketing is not enabled. We can enable bucketing by using this command. By default bucketing is not enabled. So this is to use enable only this command prompt. So if you want to enable bucketing permanently, if you want to enable bucketing permanently, we do this. So we add property in hive site.xml file. In hive site.xml file, we add this entry, property entry, then bucketing enabled permanently. So bucketing, partitioning and bucketing is not new in Hive. It is borrowed from RDBMS. RDBMS already has this bucketing and partitioning concept. Only problem with RDBMS is limited storage. So because of limited storage, they cannot apply partitioning and bucketing for all the projects. So let's create table EMP buckets. So let's go browser, name node URL. So currently there is no, under MyDB, there is no EMP buckets, right? Let's create table EMP buckets, 3 buckets. So EMP bucket is created. Currently there is no data here. Once we load data, based on the hash code value of department number column value, it will store It will create 3 buckets, and each bucket it stores data. So before loading data, we have to set bucketing hive.enforce.bucketing equal to true, because by default bucketing is not enabled. Then insert override table EMP buckets, select star from EMP. So internally, based on the column, department number column, it will internally converts department number column. Internally, it will calculate hashing mechanism. Let's go and search how to calculate hash value. How to calculate calculate hashing hash value per number, right? So you will see algorithms. Someone developed a program. They are following some rules, but it won't require. We have some hashing algorithm. Number 2 hash stored. Number 2 hash. Some algorithms are there. Or go to hash algorithm. So whenever we say department number, based on the department number value, it will find hash code value, then goes to corresponding table. Hash code is different. We are not generating hash code value. So we are storing employee data into EMP buckets, but column name department number, based on department number column we created buckets, right? So internally for every department number data, it will read value and converts into hash code value and stores into corresponding bucket. So we have only 3. Find the hash code algorithm here. Let's simply take we created 3 buckets. Right? So generic way I am explaining. Bucket 3, bucket 2, bucket 1. Okay. So assume hash code value, we stored department number. Department number first record is 11. Department number 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So assume 11 is stored here. Again we stored department number 12. 12 record. So 12 record means here it comes here, right? 12. Next department number 10. 10 means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here it will store 10. Always 10 10 department number 10 records are presented in this bucket, right? First bucket. So in this way it will find hash code value. Whenever you search department number 11, 10, directly it comes to hash code value, it finds 1, then it comes to bucket 1. In this bucket 1 it will read department number 10 records. Okay. So created. Let's go browser. Let's see, refresh. So we have 3 buckets. 3 buckets. Let's go here. Copy this one. 6 zeros underscore 0. 5 zeros 1 underscore 0, right? Okay. Let's go. HDFS. 5 zeros. 6 zeros, right? 6 zeros underscore 0. first bucket, then see what are the records are presented. So all 12 department records are presented in first bucket. First bucket. Second bucket. Second bucket. So 13 records are presented. Next, third bucket. Third bucket. So we see 11 and 14 records buckets. 11 and 14 records buckets. Okay. I said this is, I explained the generic way. But internally it calculating hash code values of number